Okay, so today we are going to talk about projectile motion for an object launched horizontally off of a cliff, a tower, whatever you want. So first thing we do, read the problem. You can read it to yourself. Next thing we always do is go ahead and draw a picture. So I'm going to draw a picture of what's happening. Let's see, so we have a good old tower. The tower is 50 meters tall. Let's see, we have a student named Tucker. Okay, he's very happy to be playing soccer outside. And he launches a soccer ball, what, 30 meters per second? And it's horizontally, so that's very important to make sure to draw in our picture. So this is 30 meters per second. And I'll go ahead and draw the trajectory of the ball. Cool. So I have my picture. So next thing I always need to do is a coordinate system. So I'm going to say anything in the up and down direction is the y direction. And anything in this direction is the x direction. The horizontal direction is the x. We'll say upwards direction is positive, and we'll say horizontally to the right is positive. So next thing I ask myself, is this object just moving in the x direction, just moving in the y direction, or is it moving in both directions? Okay, looking at this, looks like it's moving in both directions. So I'm going to need to set up an x and y table to go ahead and solve. So I will go ahead and let's set up my x and my y direction. So we've already covered free fall. So we know y direction. We have VI, VF, A, delta x, delta t. So I can think to myself, what forces are acting on the soccer ball as it falls? Looks like it's just gravity if we ignore air resistance. Let's say the problem says to ignore air resistance. So, okay, gravity is just acting in the y direction. So it's accelerating in the y direction at negative 10 meters per second squared. X direction, are there any forces acting on it? No. So the x acceleration is going to be 0. It's just moving at a constant speed in the x direction. So we can put just speed, distance, and time in the x direction because we know the x acceleration is 0. So now I'm going to go ahead and put in my givens and figure out what I want to solve. So let's see. For A, it looks like we want to find time. So, okay, I'll put a little question mark for time. So we want to find time. Speed, it's moving 30 meters per second horizontally. That is the x direction. So I'll put that in. How fast is it moving up and down in the y direction initially? It looks like not at all. So I'm going to say VI is 0 meters per second. Acceleration is negative 10 meters per second squared. If it was a problem with variables, we would just say negative g. Let's see, displacement is 50 meters, but it's going 50 meters down. So that is negative 50 meters. Cool. So now I can go ahead and look to see where I know more information. It looks like the y I have a lot more information. So I'm going to go ahead and use that to solve. So I'll go ahead and pick a good old constant acceleration equation. Okay, I'm going to pick this fun one right here. You have 3 options, but this one looks like it'll be a good one. And I'm going to go ahead and plug in all my givens and solve. So displacement, what, negative 50. We have 0 times delta t, whatever that is. 1/2 negative 10 times what? Delta t squared. Cool. So that term cancels out. That's nice. So we have negative 50 equals what? Negative 5 times delta t squared. Cool. So 10 equals delta t squared. So we take our good old square root of 10, which is approximately 3.16 seconds, is our time. Cool. So that is going to be our answer for A. We got our gold little time. So now for B, we want to find how far from the base of the tower does the soccer ball hit the ground. Okay, so that looks like it's asking for a distance in the x direction. I'll call that distance. Cool. So I'm going to go ahead and put my question mark right here for distance. Ooh, time. Isn't that nifty? We already found it. So let's just go ahead and put that in right here. And again, that's the time that we found from this point where it's launched to the ground right here. So we can just leave that time with that. We don't need to do anything nifty with that. So that's 3.16 seconds. Great. So now we can go ahead and use our good old equation, speed equals distance over time. So speed is 30, distance we want to find, and time is 3.16. Cool. I do a little nifty math, and that is going to give us about 94.8 meters for the horizontal distance. So that will be our answer to B.